Okay, well, thank you very much. I'm Gary, November, Quebec, 0 Victor.
And I'm Dan Fisher, AI4GK.
And we're from the Space Coast down in Florida near Cape Canaveral, specifically Melbourne and Palm Bay. And we'd like to share what we can do to help you find power line interference and slay it. The man you see up there in the armor, he's our mascot. We call him Mr. Mew. And if you don't understand what that connects to, we can explain it later. But that's our mascot, Mr. Mew. Down there in Central Florida, we have a lot of activity with lightning. We tend to have the storms come up in the Gulf and drop not only a lot of rain and wind and the occasional hurricane, but a lot of lightning. Each square mile in our area receives about 40 cloud-to-ground strikes every year. And so lightning is a very serious concern for us down there in Central Florida. Here's a typical lightning arrestor, and this poor specimen here has given its life for the cause. It took a direct hit, it appears. In Florida, our power company, as is probably typical with most power companies, they use a value-engineered lightning arrestor. It meets minimum specifications, but it only meets it once. And, you know, we'll be you past that. Also, they don't necessarily fail closed, they fail open. And so a power company may not have any idea that an arrestor is not working at the time. So this one here is no longer working. And a direct lightning hit can wipe out pretty much anything, lightning arresters and transformers and stuff like that. So there's a shot of a defunct lightning arrestor. What we have here is, I think, a pretty typical spectrum of noise, and I'm going to see if I can get it to play here. I don't think I'm going to get it to play. Okay, well...
Maybe I have to turn off the lightsaber here.
Okay, try that. Let's see. Well, what we've done is we've captured... I think we all know what that sounds like. Yeah, okay. Okay, that was a particularly poor example or a particularly poor condition with tremendous power line noise.
It's a great example.
Yeah, a great example of power line noise. Unfortunately, we tend to come across that quite a bit there in Central Florida. But we're not exclusive to that. It's pretty much anywhere you have AC power. What we did is we took an audio recording of that noise, and we had one of our members analyze it. We had Ken in AKH analyze that with some fairly simple software. And Clyde, KD8AN, was the one that actually made the recording. And as you can see on this chart here, you see that there are very pronounced spikes every 120 hertz, and that's very indicative of power line noise. That's the real giveaway that we have a power line noise problem. And at first blush, a lot of people will say, well, no, wait a second. Here in the United States, our power line is 60 hertz, and a lot of other parts of the world, it's 50 hertz. So why is it 120 hertz? And the answer is, if you look at the sine wave there, during a single 60 hertz full sine, we have 2 points where we have voltage peaks. And at each peak, we'll get a breakover and we'll have noise generated. So power line noise has a very distinct and easily identifiable 120 hertz component there. In the Space Coast, lightning arresters are bane. They're the #1 cause of power line interference. And in order, maybe not a scientific listing here, but this is certainly pretty close to our experience. We have as #2 problems with interference is solar installations. #3 might be vegetation or vines or tree limbs coming up, encroaching upon high voltage lines in the distribution system. And then #4, it's kind of hard to pick an exact #4, but loose hardware does happen, and we've run across a few of those. And switching mode power supplies are a real problem, especially those that are, again, value engineered, where some filtering components have been left off. and they tend to cause a lot of issues. When trying to track some of these things down, it's hard for folks to try to figure out where do you start. And certainly you can start in your own home with very simple equipment. What this is, just a simple AM radio is all that is, a little portable AM radio. Any AM radio with a loop stick will work. It has directional properties, as you can see on the chart there. Along the axis of the antenna is where a null is, so you can actually turn the radio until you hear minimum noise, and then the noise is usually in the direction of that axis. So you can start out with even the most simple AM radio and still get start to get close. Don Kirk here, WDA-DSB, came up with a fantastic antenna for direction finding and for noise situations. In the March 2021 issue of QST, he gave all of the dimensions and the directions on how to build this thing. He has licensed that to DX Engineering. This is a DX Engineering equivalent of that antenna. Very heavy duty, works extremely well, and you know, this is something we use. In my usual cheap ham attack at this thing, this is my go at the antenna. Again, it may not look particularly strong, but it doesn't need to be. It still has a loop of wire with a coax and a load, and it works extremely well for isolating out power line noise and other types of interference that we have to go after. So this is, you know, highly complex, very expensive. You know, maybe $3 for the piece of PVC. I don't remember what it was.
Tell them what the framework is.
Oh, yeah, sure. Well, obviously, you can see it's just a piece of wood in the middle. I drilled some holes in. These yellow spars here are just to kind of maintain the shape. These are wire-pulling fiberglass tubes that you buy at Harbor Freight in a small plastic tube for, I don't know, $7, $8 or something like that. So the yellow you see on there, just to maintain structure, is from Harbor Freight. The actual guts, the working part of the antenna, is the little white wire business. That's what really does the job. The yellow just holds it into a shape. Hang on to that. Careful. Hit you in the head there. One thing that's the beauty of this antenna, besides it being small enough to carry around, you don't have to have a big massive array, is it has directionality in one direction only. It has one and only one null. And what makes that really nice for direction finding purposes is you simply turn this thing toward a null in the noise and walk that way. Most other antennas are bidirectional, like a loop antenna on an AM radio, that's bidirectional. This thing here, it has one and only one direction. And so it has a main lobe of maximum response down at that end, which we don't use. And down here is a 680 ohm load resistor, which we do use. So the null is off to your left here. This is the null. So you null the noise and you just walk to it. And that's what makes this antenna so great when we're out using it. So the modeling of this thing shows it's got at least a 21 dB front to back ratio. That's not outstanding if you're talking some big massive full-scale Yagi. We don't care about that. When you're out finding noise, that's more than sufficient directivity from front to back to be able to follow your nose, follow the minimum noise, and it'll track you down and get you pretty close to a noise source. Power lines, unfortunately, make really great HF antennas. They do really well at irradiating HF energy. And so sometimes power line interference can radiate for miles. We've had several situations where we had to wander all around the county trying to find a source of power line noise. So the very large power lines are great at carrying noise along with power to your homes. A property of the power line noise, though, is you get closer to the source, you can actually use smaller antennas with a little bit better directivity to try to start to isolate down where a particular pole or a piece of equipment or a transformer might be. Dan, could you show them this thing here? This Yagi that we're going to hold up here is a commercial product, but I think you can see it's not terribly complicated, but it is quite convenient for being handheld. And so when you get close in meaning, a block or 500 feet or something like that, an antenna like this, then you can use to point at and try to find the maximum that is creating the noise. And then we can zero right in with that. So for long distances, you use a null antenna. When you get close up, you switch over to this thing. That's not the exact antenna Dan has, but it's very similar, a small Yagi, handheld Yagi. The thing on your left is a printed circuit board that has a log periodic printed on it. It's probably $5 or $6 on Amazon or something. So it's not a particularly expensive antenna, but it does have a fair amount of directivity. Again, if you're working close in, that'll work quite well. And at this point, I always have to point out that you need a radio or some kind of a receiver that has AM mode on it. You can't direction find with FM or sideband. There's just not enough energy there to be able to isolate it down, and certainly not FM. The purpose of FM is to suppress noise, not go find noise. So FM is really a useless mode. So whatever you're going to go after, power line noise or similar kind of noise, it has to have an AM mode to it. Here's a couple of our fellows. We're out on a request. Certainly, if you have 2 or 3 or 4 fellows that are familiar with the terrain, familiar with how the antenna works, and they've got some of their own equipment, it'll make it quite a bit easier. And not to rub it in, but that was January down there in the Space Coast. Yeah, they suffered mightily. Oh, those poor guys. One thing that is just kind of an operational convenience for us is that when being called out to a power line complaint, as we approach the area, we use our AM radios in our vehicles, and we tune it to either a very weak station or an unused portion of the band. And when we do that, then we're not really getting into the AGC of the radio. And by not getting into the AGC, then the loudness of the signal is pretty much representative of how loud the signal is coming in the antenna. So you can use your ear as a really good gauge as to how close you're getting to a source. And so an AM radio in a car can be put to really good effect. So just as an example, if you hear very slight noise, you're a little farther away. And if an AM station that's nearby is getting wiped out, you're almost on top of it. Here's an example where we were called out for power line noise. We found this transformer here. It had some kind of a leak. It was leaking oil, and it had an internal problem. And what's not easy to see on that right-hand shot there, but if you look on the ground, you see a small mat or a tarp. That was an oil-absorbing mat that the power company put out there. So they knew this thing was leaking. They didn't know it was causing interference yet, but they knew it was leaking. So they had it in the schedule to replace. And when we zeroed in on it and said it's causing a lot of...
One day.
Yeah, a lot of RF interference there. The next day it was replaced. You think there would be some environmental issues with this thing leaking oil, but fortunately modern transformer oil is just oil. It's not particularly dangerous. So they knew about it. RF report elevated the priority of this, and it got replaced pretty quickly. We've encountered quite a few problems besides power line where we don't have one particular person or company that we can point to that's responsible for the source of the interference. And that's why I put the onion picture up there, because when you get into that situation, and solar panels are one of them, you have multiple layers of companies and people responsible. And the reason why solar installations fall into that is because you got an owner of a solar installation, a homeowner usually. You have an installer that put these things in, and then you had the company that actually built the equipment or designed it and sold it to the distributor. And so if you isolate down any kind of interference to a solar system, it takes a lot of detective work and a lot of tenacity and a lot of dedication to try to help find what that is. Communicating the noise sources to your power company provides a benefit to them because it saves them resources and time in not running all over the county or all over the city trying to find a report of noise. Now, they are still responsible to fix that noise, but it may take their technicians or field engineers, it may take them quite some time for them to get out with their equipment to locate a noise source, and then they have to put it in the queue to get it repaired. We have found that we've built some trust up with our local power company, and when we provide a report to them, they depend upon that, and they realize we're not only trying to save them time, but we want to cut the time off of what it takes to get it fixed. So, you know, it's a two-way street here. We've had a really good working relationship with the technicians at our power company. Another thing that makes it convenient when we are out and actually find the source is we can confirm that it was fixed. In some cases, the power company will come out and they'll do what appears to be defective, or they'll replace some components, and it doesn't fix the problem. And so we'll be called back out and we'll say, hey, you know, great, you guys did good replacing that, but the noise is still there. And we'll try to isolate out exactly what piece of equipment is doing that again. So it's a kind of a feedback loop that if we're out there we being our team, our Space Coast RFI team, if we're out there finding it, we can have a chance to go back and confirm that it was either fixed or we haven't found the problems yet. If you do have power line interference, most hams are kind of at a loss. They're adrift as to what do you do, where do you go? And we find that the response to our requests to help are kind of fall into three categories. Well, you can give up HF, right? That's a real option. Let's just give up HF. It's too noisy. You don't want to go there. You can go it alone, which means you could try to report it to the power company or officials or wherever you think may have the authority to get it fixed. Or you can contact a local club or RFI team. You know, that's kind of what we're trying to drive you toward here. Now, not every area obviously has an RFI team, and not every club does. But certainly, many of the larger clubs do. And as a resource, you could contact the ARRL directly. They have noise fellows there that know how to ask the right questions, try to get enough preliminary information about the issue, and then they have some suggestions as to who you might be able to contact. So the league is certainly a really viable path to try to find help for power line noise. So if you try to go it alone, you're going to have a real tough time. It's going to be a tough experience for you. You may not be communicating the correct information to the power company. You know, when they hear noise, they're thinking mufflers on cars or trucks or something. You know, noise may not register with them. And if you're communicating with others, and others meaning like regulatory agencies, either for your city or for your state utility regulatory agency, you also may have difficulties explaining properly to them what's going on. You might not know what to do if you get no action. You know, you report it, noise, day after day after day, and nothing happens. Well, do you call the power company again, or you know, at what point do you kind of elevate this or raise the priority of your request? You could actually be making the solution more difficult to arrive at by complaining to the wrong people. And how can that possibly happen? Well, if you call up City Hall and say, hey, I've got power line noise, typically at the level of City Hall, they'll kind of say, well, we need power. We need power lines. We're not going to deal with you. So, I mean, you'll get a very happy, supportive response, but nothing substantial, usually from local officials. So some examples, that'd be city council, county officials, public utility commissions, are generally less effective than trying to find the correct person or parties inside a power company to make a complaint to. You might be tempted to just run right off and complain to the FCC. Hey, power line interference, shut them down, fix that. Well, there is enough power line interference out there that the FCC does not want to deal with that directly, at least at the first blush. What they will refer you to is back to the ARRL, and the folks at the ARRL then will ask the correct questions, try to correlate your problems with some past problems, and could put you in touch with local teams or local experts that might be able to find a solution for you. So the league is certainly a viable alternative. But going directly to the FCC, you certainly have that right. That's your right as a citizen to do that. They'll bounce you right back over to the ARRL. Expectations. Well, you know, you call up the power company today, you expect it fixed tomorrow, right? Not usually, no. Some power companies are very responsive, and it's great to hear those kind of reports. Typically, in our area, the power company website says they'll get back to you within 10 to 20 days. You know, real firm commitment there, guys. And in our case, you're really lucky if you get any feedback at all from the power company. It just goes into the black hole, and you don't know what's going on. You keep calling up, making more reports, nothing happens. There's no feedback. And that's sad because it's very frustrating. But there are some very good reasons for that, at least if you're making your initial report through the website of a power company, is the power companies are very, very concerned about cyber activities on their website, about being hacked, about shutting down facilities or damaging facilities. So when you go to a power company's website, usually you're just limited to filling in text blanks. That's it, nothing else. You can't upload files, you can't, drop and drag or anything. You can type in what you can type in, and that's it. And that's the safest way for it to be for a power company, and we kind of understand that, but it also somewhat limits your ability to communicate your problem to the power company. So the cyber attacks have happened. There's a link. I realize you can't read that, but on our presentation, if you want to download it, or even through the ARL, they'll give you links to where cyber activity has shut down utilities. The particular link I have up there is for a pipeline during a particularly cold winter some years ago. I don't want to put out the wrong number, but a cyber attack actually shut down this natural gas pipeline from the southeast to the northeast where the demand was highest. And it took several days for the companies to be able to get that pipeline back in service. So the power company's concern is real here, that by limiting how much you can actually put in a report. One thing that is also available to you usually is a report of a phone, just a phone call. There's a trouble number you can call. And they may be able to accept additional information from you. And they can enter it in their system and consider that relatively secure. And so if you say, I have particularly loud noise at Main Street and Park Place, or whatever you think you found, or a RF team has found, they can generally enter that themselves, and that will also lead to perhaps getting a quicker resolution. If you are able to, through the power company, though, it's recommended if you try to capture any kind of a work order number or a complaint number, supervisors, they'll only give you their first name, but a supervisor's number, in the hopes of there might be some way to track this. And why would you want to track it? Because in 10 or 20 days when nothing happens, you want to kind of go back and refer to your notes or refer to a work order number or something and say, oh, well, I reported it back in, nothing's happened, here's the number. And they can have a chance of go looking that up in their system. When you use a local RFI team, there are quite a few scattered around the country here. The experts in those teams can usually go out and find the interference in very short order, and then that can be reported back to the power company very specifically. And it aids in not only making sure you find the problem on the first time, but also connects to the power company to say, hey, we know where this problem is. You don't have to spend a lot of time chasing your tail to find it. We've already found it for you. The best method and examples of how to report the problem is if you can get work order numbers or have some kind of tracking system. Again, sadly, our power company, even though they're fine folks, there's no way for them to feed back to us on the Space Coast what they're doing for a power line report. We have to have back channels, or there's some alternate means perhaps that we can try to find out what's going on. But officially, once a report is made, no one other than the original customer has any access to that information. There are quite a few, probably 4 or 5 really well-qualified RFI teams around the country. One that we've worked with quite closely and shared a lot of information with is the fellows up in the New England division. They have 50 members and 7 sections up there, so they've got a lot of broad experience, not just with power line, but all other kinds of interference that could be tracked down. Also, ARDC, who is here at one of the buildings, that stands for the Amateur Radio Digital Communications Group, they made available to hams or clubs grant money to either purchase equipment or to provide some kind of assistance to hams. And one of the things that they wanted to fund was spectrum protection. Well, trying to keep the spectrum clear of power line noise and switching mode power supplies was one of their primary goals. And so we were able to apply to the ARDC and get a grant to buy some nice equipment that makes it really easy to find some of these problems here. So several grants have been made to the RFI teams around the country for getting some equipment. There's always work in progress for RFI teams. The Northeast Division is New England Division is no different than us. They've come across all kinds of sources of noise besides power line and solar systems, LED lighting, power supplies, electronic devices. And we're all still learning. I mean, there's so many types of electronic equipment out there that we're still trying to figure it out. When we hear some interference or noise, we'd like to be able to put it into a database and say, oh yeah, that's this noise over here. Well, we're not quite that far yet. Other than the normal 120 hertz signature power line noise, any other kind of noise is not well defined. And so when we put our heads together, we're trying to make that easier and a little bit more efficient for all of us. The RFI team can provide follow-ups. We've had to do that a few times. In the New England division, fellow W4DD has some software, really powerful software that merges mapping and GPS and directional headings of interferences found on their equipment. And that can find or triangulate basically into interference that you may not even have access to in terms of a citizen. It may be on private property. But the W4DD software can triangulate that fairly closely and identify that for the power company. The power company can get in there and fix it. You can't go in there with an antenna to check it. So his software is really, really good for that. If the power company is not responsive, that's never happened to us, has it? No, they're always responsive. Well, now, if the power company is not responsive, teams have experience to know how to elevate the visibility and the issues that you're having here. Usually, the next step for for an RFI team is to go to the DARA and ask them for assistance. And they have the ability to write letters or make suggestions or contact CEOs of power companies. And in some cases, they get immediate attention. In other cases, they get ignored. That's just the nature of the beast. And so the operating agreement between the ARRL and the FCC says if the ARRL can't get satisfaction, then it gets bumped to the FCC. If it comes from the ARRL to the FCC, then it has some really good visibility at the FCC, and they can take action. But the FCC does want you to go local first, then through the league, and only if the league can't help solve it, then ultimately to the FCC. When you go to the ARRL and request assistance, either if you don't have an RFI team nearby or you've reported things and you're not getting any satisfaction, their members up there have a checklist. They have a bunch of questions they want to ask. And the reason why they do that is so that they can help identify a suspected type of interference and also perhaps add it to a database so that we can capture that and follow that that information on to the rest of the teams. So there are experts up there have a checklist, things they can ask you. We have a checklist on our website that does the same thing. We ask the same questions. We maybe pretty up the form a little bit, but we ask the same questions that the ARRL will want. Here is a letter that after a local contact didn't produce any action at all. We had to elevate to the the ARRL. The league then wrote this letter to the CEO of a particular power company and asked them for assistance in solving this, for citing perhaps some FCC regulations of unintentional radiators are interfering with licensed services, and that can get some response usually. And it also points out in the verbiage there that if reported to the FCC, this would be considered harmful interference. It would shut down not only amateur radio, it could shut down scanners, it could shut down TV, it could shut down public service communications. I mean, you could extend that quite a bit, even though the original complaint is from an amateur radio operator. So once you got the power company's attention, obviously you got to be a pleasant pest. You got to keep their feet to the fire, follow up, and you have to be reasonable. You got to give them a chance to fix it. So what's a reasonable amount of time? 30 days, 60 days, 90 days? I don't know. There's no defined answer here. I think 60 days would certainly be a long time, but so reasonable is in the eyes of the beholder. In the power company, reasonable may be forever. For Ham, it may be yesterday. But just to point out, though, once the ARL does make a complaint, then keep in contact. Keep your visibility high and see if you can keep pressure on them. Now, there's certainly some mitigating circumstances where a power company may not want to fix something right away. And we're all reasonable, and we're aware of some of the emergency situations that hams may be called upon to serve. And in our case, down in the Space Coast, that's hurricanes. We get a few of those things. And when they do, it tends to have a real big drain on the infrastructure. There's a lot of repair activity going on. And that repair activity could even extend beyond just simply restoring service. It could be temporary situations where eventually service has to be replaced. The power company has to come back and put in better equipment. And so there's some logistics behind the scenes that you may not be aware of. I'm not saying don't keep complaining, but so there are some issues, though, where power companies truly won't have the capability to get at a noise complaint right away. Well, it could, yeah, it could fix the problem, if they got to do something like that. One thing, is the last point on here is for underground service. Many companies are trying to make the push to put all their service underground. And so if you make a complaint, oh, I've got noise, it's wiping me out, and a supervisor looks at the list and says, oh, well, we're going to put that underground in 6 months. We're going to ignore that. You got to make a call there. Is 6 months of not operating HF, is that reasonable to you? It may or may not be. But if we can isolate down the exact problem, a pole or a transformer or an insulator or something, that's not a big expense to them. And yeah, sure, it'll go underground eventually. But, power companies not knowing it can be isolated that closely, they may want to procrastinate and say, well, it's all going underground anyway. We won't do anything about it. And we've seen that. We understand. Here's the form we have. Again, I want to acknowledge the ARRL. It's all the information that they ask for on their website. I just put a pretty picture on the top of it. And we put it on our website down on the Space Coast. It is a fill-in-the-blank kind of a form. You put in the text of all the things you think you need. There's a comment section on the second page. If you got comments or ideas, you put it all in there. And then it says where you mail this thing, and we get at it, and we contact the complainant. Here's some of the usual suspects. Right out front here is Dan, IF4GK. He's the chair of the RFI team down there in the Space Coast. We're sponsored by the Melbourne Club, which is called the Platinum Coast Amateur Radio Society. So we kind of are an offshoot of them. However, we intentionally downplay that connection, and we call ourselves Space Coast RFI team. The reason for that is we don't want to give hams the idea that you got to belong to the club or some club to get help for RFI issues. So we downplay that, even though behind the scenes, certainly we are sponsored by the Platinum Coast Amateur Radio Society. Again, there's some more of the usual suspects. And again, that was probably January or February. I don't remember what it was. Dan, you got a comment on that? Was that?
Well, we have, like Gary said, this is our original cast of characters that form the group, and these guys they kind of look like an F Troop bunch of guys, but we've got 1, 2, 3 guys there. The guy on the far left, the heavyset guy, he's got, 60-some patents? Yeah. He's an antenna guy for a defense contractor, and he's
a scientist at Harris.
He is a senior scientist. Yeah. And so these guys are really brilliant. The guy, I point there, they can't see. Yeah, they can't see. The guy in the back is, he's also a pretty smart guy, brilliant guy. So we have, I think we have on the Space Coast, we've got several defense contractors, we've got aerospace companies, and a lot of those people are ham radio operators. So we have we kind of have the pick of the litter of brain power behind this thing. So, you know, it's a good group. One of the things that we try and do is like Gary said, you know, we have contacts with the power company, and so we have phone numbers and email addresses that we've gotten over the years. We have a very good working relationship with the guys on the ground level at the power company, at Florida Power and Light. Can I say that? Yeah. And so all it takes is a phone call, and you know, hey Paul, we've got this going on, and he'll come out and he'll take care of things. So we've gotten that kind of the workaround around the firewall, if you will, of getting into the company itself. He's not a ham, but he's very ham friendly. He loves hams. The investigator in the Daytona Beach area, which is just the next county north of us, is a ham. He just retired, so I'm not sure what they're going to do about filling his spot. But you know, it's like Gary said, if we get to a point and we have a pretty good suspicion of where it is, we contact the ARRL lab in Newington, and they have contact people for just about all the power companies. They have contact people for the solar power system companies. So he can pick up the phone or send a letter to, say, Generac, and say, hey, we've got a system, it's one of your systems, and it's over here and it's causing problems. And they can they'll get a hold of one of their local installers, and they'll send out some new equipment and get the problem fixed. So it's we've made, not just us, but in general, we've made good inroads to getting the stuff solved. So if you are plagued with what you think is power line noise or any kind of local RF interference, I would say contact, first of all, your local club and see if they have if they have anybody who's capable of going out. And I mean, you can do it yourself. You can go out and look for, you know, for power line noise. But it's not necessarily going to be the problem that you find is not necessarily going to be what's causing your interference. So, but it's not rocket science. Like Gary said, we started out with simple AM radio with a loop antenna. Gary's got a AM/FM shortwave radio with the loop antenna in it, and you know, the antenna up there, it's a homemade. It's basically that, but it's another homemade version, and that's what we did. So it's not insurmountable. It's not the end of the world. You just have to be persistent with it, and again, try and find somebody at your local club. If you don't, then get a hold of the ARRL, and if you need help in, I hate to hesitate to do this, but if you need help in getting a hold of somebody, you don't know where to go, the next slide is going to have our contact information, and you can contact me. It's my call sign, AI4GK@arrl.net. Makes it real easy. Send me an email and say, hey, Dan, you know, I've got this problem. I can't seem to work around it. And so we'll get you in touch. You know, I mean, if you want to pay my airline ticket, we'll fly out there and and work on it. No problems there. I'm retired, and you know, the boss at home, she lets me travel to do stuff. So as long as it's not coming out of my pocket. So anyway.
Yeah, I wanted to mention, Dan, when you said we've got a good working relationship with the investigators, the field investigators with the power company, we have no control over their work assignments. That comes from their supervisors. However, the workers do have some latitude as to how they arrange their work and how they arrange their path to get to different jobs. And if we happen to contact a local investigator and say, we worked with you before, can you check this out? At an unofficial level, it can usually get done fairly quickly. So again, we can't control his work schedule, but we can suggest a method of attack for some of the local fellows.
Yep. And our local guy will say, all right, go ahead, give me the information. I'll usually, send him a copy of our form. Just give me the information, but it's up to the ham who's having the problem to make the initial contact with the power company. I can't file your report for you. You've got to file it. And that's usually not real difficult. Although sometimes I know with our power company, and I won't mention the letters FPL, they have their form, if you want to call it that, you've got to go like the onion. You got to peel back the layers to find out where the form is. So to fill out, and you've got about 2 or 3 radio buttons and a couple of tick boxes, and you have a field about that long where you can maybe put some text in. So so that's where people like us come in handy, because I can get a hold of Paul or whichever other investigator. I can say, all right, this is what this guy or this gal is having, and this is the problem, this is where they are, and that really helps them out.
Yeah, I think that's about it, Dan. I mean, we're trying to be a service to hams. We enjoy operating, and we see the pain that happens when interference occurs. And we're trying to put our expertise and heads together to see if we can help solve that. We're not 100% effective, but we're pretty good. We're probably in the high 80s or 90s or something like that. We're pretty good. So I'm not saying, hey, we're great. I'm saying we want to be service to hams, and we want to help hams and not only enjoy the band, but be a service to amateur radio. So here's our final slide, and we got a couple of pieces of equipment I want to show you real quick. We're not actually going to turn them on. I don't think we're demonstrating, but we want to show you what we were able to get with a grant from the ARDC that has really improved our efficiency there. So if you need to contact me, I am in the brochure, November, Quebec, 0 Victor at ARRL.net. For whatever reason, Dan's information is not in there, but as he mentioned, it's AI4GK at ARRL.net. A copy of the presentation is on the Platinum Coast website at that link. Don't bother looking at the link. Just go look up Platinum Coast RFI and it'll pop up. So we want to share this information with hams to hope it'll benefit somebody. So I want to do just a quick show and tell, basically, and then we'll ask for questions here. So we'll start with this.
Right there.
Oh, okay.
Under the computer. I think.
Okay, well, yeah, sure, we'll use that. We'll go for that. This particular piece of equipment is manufactured here in the United States, and it is a sophisticated form of a spectrum analyzer, and it's optimized for locating power line interference. This is the piece of equipment that the power companies will use, at least if they're well-funded or they're, dedicated in trying to find problems. This is the kind of piece of equipment they'll use. So you want to just kind of tilt it forward toward them there. So it's got an LCD display and frequency knobs, and I think it goes from 500 kilohertz to about 2 or 3 gigahertz or something like that.
Basically an audio spectrum analyzer. Somehow we didn't turn it off the last time we used it, so there it goes.
Oh, it makes a pretty picture. Makes a pretty picture. So, and going after power line interference, then the folks that design this thing know what they're looking for, 120 hertz spikes, and it is optimized to find those. However, it can find most other kinds of power line related noise, hiss or corona or anything like that. So we did purchase this through the ARDC grant. We want to thank ARDC for doing that. Because it has been a service to hams, and we like using it to help hams. So it's kind of a portable spectrum analyzer. And in this particular case, that spectrum analyzer did come with this small Yagi antenna here. They kind of came as a kit. This is kind of a nice, easy thing. You can't use that for satellite contacts because it's at 330 megahertz. I don't know why they picked 330 megahertz other than it makes a nice convenient antenna, and it's easy to point at what you think might be a problem. So so it can't be a ham antenna, but it's at 330 megahertz, and that's a very, very typical frequency that most power companies will use close in to try to isolate out a problem. I'll hold this up next here. This is made by MFJ, or was made by MFJ, but it's just an ultrasonic ear. There's nothing real terribly sophisticated about it, other than the fact that through the middle of it, which is difficult to see from back there, but it has a focus hole in it. And you can actually zero in on a particular piece of equipment, meaning a single insulator or a single piece of hardware. The focus is so close on this thing that you can actually identify one individual component. A drawback to this that we've made aware of very quickly is that the source of the information has to be outside in the open. If the problem is inside a transformer or inside a piece of equipment or something, this hears nothing. It hears birds, it hears bugs, it does not hear interference. So the source of the interference has to be outside of a piece of equipment, and then this can be pressed into service to try to help isolate the issue. Ultrasonic.
It's ultrasonic.
It's about 50 kilohertz.
Now, the people who made that device that we just showed also make a very similar device, and they probably charge what, about 10 times?
Yeah, 10 times.
Yeah, I would say 10 times of what you could got. It's a better quality piece, but it's like 10 times the amount. Now, this is an ICOM 705, and the nice thing about that is
It's lashed in.
it is lashed in. Power?
Yeah. Oh, there it is.
Power should be right there.
It should be charged up.
Yeah.
I'll get this one.
There we go. It was last night.
Yeah.
And the nice thing about that is it's it goes in AM mode. It goes multi-band, and if somebody has a problem that's not power line, okay, we do if we do the analysis that we showed you, and we determine it's a not power line, and we can tell a lot of times also just by listening to it, because power line noise you end up being able to hear. So there's like we have a gentleman in our county who is he's got noise that's probably not power line, partly because all the power lines are buried in his neighborhood. And so we went out. We didn't have this with us. We went out, and we think we narrowed it down to his neighbor's house. We're not 100% sure. So we're going to go back out with the 705 and the flag antennas and see if we can, we're going to listen on his frequencies that he hears it the worst on, and then we're going to track it down that way. So that project is, it's a work in progress. Now, what else do we have? That's about it. It's about all we have for show and tell. Oh, we got the national radio. All right. You want to talk about it?
Oh, you can.
Okay.
Radio's still on. That's okay. It's fully charged. We'll make contact with it.
Now, this is a piece of equipment that one of our members had purchased, not this very same one, but he says, look, guys, he says, this is, I forgot what we paid for this, but it's not real expensive, but it's really handy when Gary gets it all screwed together. Now, this is not coax cable. This is it's just a wire loop, and
Wire loop with a compass on it, kind of tell you which way to go. It has a preamp in it. It is tunable, so you can tune a particular frequency. I think the lowest it goes is 1 megahertz, and I think it goes up through almost 200 megahertz, depending on what loop you plug in here.
Yeah,
so
it comes with a whole slew of loops, too.
Yeah. Now, this thing by itself is not a receiver. It's just an antenna, but it has these great features where it's tunable, it's got high and low gain, and it also has attenuation that you can throw in here, too. And there's a lot of times where the signal is so strong, you got to throw a lot of it away to be able to get a decent null or isolation on it. So there have been instances where this has been the right tool to go after something. But we have to have an external receiver of some sort, the ICOM, or even I've used a shortwave radio, an old Radio Shack shortwave radio that works a fair amount of the time. The ICOM is the ideal one, though. So this was made by National Radio. There actually is a successor company to the original National Radio from the 1930s. And they don't make much anymore, but they still make this that helps hams out. So this is available online for really low bucks.
It's just another tool for your toolbox.
I think that's all we've got.
Yep. Any questions? I think I'll do what they did earlier.
Okay, why don't you go down, and I'll hand you the mic.
Hand you the mic.
Yeah.
and I'll-
Yeah, that way we can all benefit from the question. You may not be able to benefit from no answer that we might not have, but
Yeah, one more thing. You guys might wonder about the yellow vest. One thing that we found out is that if you walk around town with a yellow vest and a hard hat and a clipboard, people leave you alone. Because
oh, also if you got a radio talking to guys,
yeah.
you look
yeah.
real official that way.
So, yeah, we had one time before we had the vest, some lady, and good for her. We were in her neighborhood, and she drives up, she's in a minivan, and she goes, "What are you guys doing?" So we had to explain everything. So now we had, actually, I found a guy at Orlando Hamvention who does, T-shirts and hats, and he had a vest, and I said, "Can you do this and that?" So we have, radio interference team on the back. We have our Platinum Coast, our PCARS logo. So, this is who we are and what we're doing, and people tend to leave us alone.
Yeah,
Okay,
we don't raise suspicion when we're doing that.
Yeah, if you got a question, come on up and come on up.
I was just going to ask about the solar power. Is that only when it's connected to the grid, or?
No, some solar systems have battery backup, and their battery chargers connected to that. So not only does the solar system charge the battery, which is a power supply, but then it extracts the power from the battery and delivers it to the grid or electric vehicle or whatever. So there's multiple power supplies involved with that. So the short answer is, if it has a battery in it, it could be day or night.
Yeah, I've been chasing a bunch of power line noise problems down with Appalachia Power. I've got a cabin outside of Lynchburg, Virginia, having fits. But anyway, one thing that can be handy too in chasing noise down, or at least kind of giving you some ideas, if you have a mobile rig, dual band, some of them listen to air band. Tune that down to like 136 megahertz, somewhere in that area. And just drive around, and if you pass poles that are really noisy, you'll hear the noise come up.
Yep, and the real key to that is the airband is AM.
Yes, and it's because it's in the AM mode, but it's just a convenient way, and it's also close enough to the 2-meter frequency that the antenna is responding. So it's kind of a quick and easy way of kind of hearing a few noisy spots to give you a place to begin your search.
Another aspect to that is that if you're hearing interference on the aircraft band, I think the FAA is going to want to know about that. The FCC is going to jump on that. If you can report and you can say, hey, this is affecting the aircraft band, that'll raise a whole bunch of flags. And what you're saying also, we were going to mention it, and I don't think we did, is when we're going into a ham's neighborhood, well, you did mention that, didn't you? We'll listen on an AM radio.
Yeah, AM radio in the
And
car.
we'll listen for noise as we're driving in. That kind of gives us an idea of where to start looking when we go on foot. Next.
Sometimes you get lucky. We've been lucky a few times with the AM radio trick in the car.
Okay. I guess kind of build off of his question. The solar systems you mentioned, like suppose you have one that's totally on private property, a closed system and that. Do you have any recourse there, and do those cause any problems? Because we've got quite a few solar systems on houses in our neighborhood Now, I don't think there are any problems with them that I know of, but I was just wondering, what do you do when you're dealing with something that's privately owned?
Well, there's the multiple layer approach of the onion. If you know your neighbor fairly well, you may be able to start very gently in that direction. If you don't know your neighbor or you do not wish to approach your neighbor, a couple of options are you could see if there was any building permit pulled, and that'll give you the name of the installer and the name of the equipment. I think the next stage beyond that would probably be contact the ARRL, and then they would try to find some local team or an expert that could come out and isolate out a particular solar system. We've had some solar systems repaired in very short order. Sadly, we've had one solar system that took over a year to get repaired because the homeowner was uncooperative. And, but ultimately, it got repaired. Dan, there's
And normally, the solar companies they'll repair that or have that problem repaired at no cost. Sometimes the homeowners are going to go, well, you call the guys out and it's going to cost me another $10,000. No, it's free. They have to fix the problem.
Just a technical question regarding the loop that you showed at the beginning of your presentation. It showed the 600 ohm terminator. What was that other device on the other end of the loop, and what are the details on that? Transformer or something?
I'll let Gary talk about that.
the terminator where the null is a 680 ohm resistor. We're not quite sure how Don figured that out, but it does work, and we haven't monkeyed with it. On this end is simply a balun, a 4-to-1 balun. That's the guts of a CATV twin lead to coax converter is all this thing is. So it's not particularly sophisticated. It should be available. Now, it's not optimized necessarily for HF, but generally looking for power line noise, we got a lot of microvolts, and we can afford to throw a few away on a balun that's not optimized at HF. So, but that's all this is a 4-to-1 balun.
And
Well, it's like a baby rhombic, yeah. But the fact that it is so very short compared to the wavelengths we use and the way it's terminated gives us that null that really makes this an ideal antenna for chasing stuff down. We really like it. It's not efficient, you know, you're not going to have a lot of QSOs with it. In fact, 0 QSOs, you can't transmit into it. But for nulling out noise and chasing them down, it does the job.